Hello everyone, welcome to Mechanical Engineering Design and Innovation course. Myself Dr. P. Rajkumar, Assistant Professor, Department of Mechanical Engineering. The topic for today's discussion is General Considerations in Design. The aim of the present session is to make you to familiar with the general considerations that we will consider while designing a product or process or system. At the end of this session, you will be knowing what are the general considerations, and by considering those factors, how to design a product. So let's start. So these are the different considerations we have to consider while designing. Either it can be a product, or it can be a process, or it can be a system. So what are all those factors? The first factor is types of load and the stresses that are acting on the product. Kinematics of the machines, selection of the materials, form and sizes of the parts, frictional resistance and the lubrication, economical features, use of standard parts, safety of operation, and the workshop facilities available, number of machines to be manufactured at a time, cost of construction, assembly. All these 12 parameters we have to consider while designing a product. So let's discuss one by one. So the first factor is type of load and the stresses caused by that load. So here you can see the different types of load that are acting, that can act on the different components. The first one is what is the first one? It is the compression load. Second one is tension load, or shear load, or torsion load, or bending load. So we have to ensure the product is withstand, or it will withstand for the compression failure, it will withstand for the tension failure or axial failures loads, it will withstand for the shear failure. So whatever load that is acting on that product, it should withstand all these types of load. Sometimes that component will withstand only one stress, one type of stress, and it may fail in another type of stress. So if that component fails either in compression or in shear, then the failure is a failure, because if it is fails in one type or 10 types, the failure means failure only. So we have to, while designing the product or component, we have to ensure the product or the component is withstanding all types of the loads that are acting on it. So these are the different loads that can act on the component. So coming to the second one, what is the second one? Second one is the motion of the parts or the kinematics of the machine. For example, we are working on the assembly of a product. So during that assembly involves two or more parts which are in motion or which are in contact. So while designing the two parts which are having the relative motion, we should ensure its kinematics is satisfied, whether those two parts are having the rectilinear motion or the curvilinear motion, or they are having the constant velocity during the rotation, or they are having the constant or the variable acceleration. We have to ensure with respect to kinematics, those rotating bodies or the movable parts are satisfying the kinematics requirement, because we have to ensure whether the parts are rigid parts or they can be subjected to deformation. We have to ensure the kinematics part also satisfied. So that is the second part of the design we should consider while designing a product. The third one, selection of materials for engineering purposes. So this is the most important step, because each design, if I select a different material, each one can create a new design. That means, for example, if I design a chair with a wood, that can be called as a product. If I design the same chair with some metal, then that can be called as a new product. If I design the same chair with some fiber or plastic, that can be called as some different product. That means everything is same, only I am changing the material. That's why while designing the product, the selection of the material plays very important role. While selecting this material, we have to consider the availability of the material and the suitability of the selected material for the given working conditions, and the cost of the material and the mechanical behavior of the material also we should consider while selecting the material for that particular product or process. And the fourth one is the form and size of the parts. So, what are the dimensions I should consider for a particular product? What is the maximum dimension and what is the minimum dimension? Sometimes we will be having some limited space to hold or to accompany that product or component. For example, I cannot design the gauge for 1 meter length because I have to housing, okay, the gears will be having housing and I have to accommodate the gears within a limited space. So, that is one of the restriction, and at the same time the manufacturing of the gear of 1 meter also not possible. So, we have to consider what is the form and what is the size that the product or that component will be allowed. You have to consider these two factors. And the another factor is frictional resistance and lubrication. For example, in the design, if we have any rotating or movable parts, then we have to ensure the friction between those two parts is minimum. If you are not ensuring that frictional, or if you are not considering the frictional aspects into the design, then that design may fail due to excessive friction, or the design may fail due to lack of lubrication. If the lubrication we are considering also, we have to select the type of lubrication we have to use for that particular product or process. Whether we can use dry lubrication, or we can use wet lubrication, or we can use mixed lubrication. For example, if I am using the wet lubrication, then which kind of lubricating oil I have to use? Clearly we have to define, or we have to select that particular lubrication. Let us say wet lubrication. In that wet lubrication I am using the vegetable oil. So, if I use this vegetable oil for my lubrication purpose, whether that design is it okay for the design, or it will cause disturbance, or it will cause failure with respect to other parameter. I have to study all those things. If I use vegetable oil as the lubrication, whether it can cause any frictional damage, or whether it can cause any corrosion resistance, I have to study for all those parameters. Okay. So, the next one is the convenient and the economical features. So, while designing that product, we have to consider the economical features of that product. So, the adjustment for wear, the starting control, stopping levers, so everything, how to operate it and how that parts can be changed. Because for example, if I am designing a product or assembly which is very difficult for assembly, so while doing the designing I have to consider DFMAE. That means design for manufacturing, assembly and environment, DFMAE. All those parameters I have to consider while designing a product. And the next one is use of standard parts. So, for example, if I have a shaft of 11 mm diameter in my design, but that 11 mm diameter is not a standard part, still you can fabricate or you can manufacture that 11 mm shaft, but whenever any breakdown or whenever any damage happen, the replacement of that 11 mm shaft is very difficult, because that 11 mm is not a standard dimension. So, if you want to replace, either you have to fabricate that shaft on your own, because you won't get that product in the market. So, that is why in order to accommodate that exchange the component, we have to use the standard parts wherever it is possible in our design. While designing the gaskets, lever, brakes or bearings, anything, or the couplings, anything, brake pedals, whenever we are designing, some standard parts. Try to incorporate the standard parts in your design. So that is the seventh parameter that we have to consider in the designing. And the eighth one is the safety of operation. So for example, you are designing a new boiler. So while designing the boiler, you have to consider the safety of the operator, because you know that the boiler will be with high pressure. So if you are not considering your design for high pressure conditions, then it cannot be called as a good design, because it won't ensure the safety of operation for a customer or the person who is operating that boiler. So you have to ensure the safety of operation for that particular product. The rotating parts, let us say consider the rotating parts. For example, you are designed a product for 10,000 RPM, but you have not provided any housing for that component. So it cannot be called as a good design, because the 10,000 RPM while rotating, it may cause some noise, or it may cause some disturbance to the other equipments or other operators, or it can cause some damage to the person who is operating. So if you provide the housing for that components or that product, then you can minimize or you can avoid the safety issues concerned with that rotation. So that is why while designing a product, you should consider the safety of operation. The next one is workshop facilities. For example, you are generating any curvature part. So for that, whether any facilities are available to generate that curvature, because while designing the product, you have to utilize the resources available within your area. So what are the workshop facilities I have? So whether I can create this design with available facilities, all those parameters you have to consider while designing that product. For example, you have created a product, you have designed a product which does not have the facilities to fabricate that one. If you want to fabricate that one, you have to send that small part to another company or another country. So that is only one product or only one component. So that means you have to send your requirement to the other industry that I need this product, required quantity is only one. Only one, if you say that another industry also, even though he is having the workshop facilities to produce that one, he won't produce. Why? Because the order quantity is very less. So that is why he won't do. So in order to avoid all those issues while designing a product or process or system, we have to consider the workshop facilities available with you. And I told you just now that the number of machines or the number of components that are to be manufactured also you should consider. If the number of parts to be manufactured are more, then you can set up the different manufacturing facilities like flexible manufacturing systems you can use. You can accommodate the CNC machines to produce all those products. Another factor is the cost of construction. What is the cost that product fabrication is involved? Because to fabricate some small part, for example, the plain part, it requires a less cost. If my product or my design is having intricate shape, that means some cuts, some undercuts, some curvature shapes, some circles. In that circles also, I am restricting the diameter of the circle. That means it should only 10 mm is 10 mm. If I say these kind of restrictions, then obviously the cost of construction will increase. And if the customer says I cannot bear that much cost, means it is again leads to a failure design. That is why while designing you have to consider the cost of construction also into account. And the last parameter is you have to take the assembly parameters also, because we know that every machine or the structure must be assembled as a unit before it can function. See here the car, because we will be fabricating the car individual parts at a different shop floors, and once that all the different components are fabricated, then we have to assemble them as a unit before coming into the actual functioning purpose. So the designer engineer should also have some idea or knowledge on the final location of any machine or the design component that is going to be assembled, and he should be in a position to anticipate the exact location and the local facilities that are available for the erection of individual components. So, all these 12 parameters should be considered while designing a product or process or component. Then only whatever design you have designed it can be called as a good design. So, these are the references and textbooks for further learning. Thank you.